Okay, we're going to call this empirical and molecular formulas. Okay, so we're going to call it present composition empirical formula and molecular formula. Okay? The empirical formula of a substance is the smallest ratio of combination that the elements involved can have. Okay? So what we're going to do when we do empirical formula, I'm going to give you an empirical formula, and then we're going to determine the percent composition. Then we're going to take the percent compositions, and we're going to see if we can redo the empirical formula. Okay? Shall we? Okay. So the empirical formula that I'm going to give you is calcium chloride. Now what you see with CaCl2 is that it is the simplest combination of carbon and chlorine, of calcium and chlorine, right? Isn't that true? Yes or no? You with me? Okay, good. Now, so this is the way you do the percent composition always, regardless of how complex the particle is. We're going to do a couple of very complex molecules. But the only difference between this, finding the percent composition of this particle, and a more complex particle is simply additional steps. All the steps are the same. You just make additional steps. Okay? Yes? Now you may ask, well, Mr. Darcy, can you give a recipe to find percent composition? And I will. Okay? The recipe is, could you give me some paper towels somewhere? Do we have paper towels over here? Over here, Ishmael? Just give me just a few. Not a lot. Not just a bunch, a half a bunch, a medium bunch. A medium bunch. It's very scientific. Say bunch. Thank you very much. Okay, so this is the recipe, the procedure, if you will, to find the percent composition of any particle. Okay, you ready? Step one. Step one. Find total atomic mass of particle. Okay, that's the first thing we do. What's the in my class, you know, when you go to college, they may do things differently, or in IB, but I like to keep things simple. Just round off to the nearest whole number. Just give me mass numbers. Okay, just give me mass numbers. So in other words, if you give me mass numbers, what's the mass of chlorine in your periodic table? Anybody? Anybody? Anybody find that? They're looking. I know it's between the book. It's like it's trying to find a star in the heavens. It's in the book. You might want to go to index and see periodic table. Chlorine. But what does it say? I'm trying to make a point. 35.4. What is it? 35.453. And that rounds to simply 35. Right? You get it? You understand? So chlorine is 35 and calcium is 40. Right? So you just round to the nearest whole number. Clear? Okay, now, you find the total mass of the particle, the total atomic mass. So that's 40 plus 70. Ishmael's looking at me like quizzically. Isn't that 40 plus 70? Yep. Right? Yes or no? Yes. You okay with that? So it's going to be 170.
What?
I'm sorry. 110. Okay, now remember, that's one particle, not one mole of particles, just one particle. Clear? Are we okay with that?
Yeah.
So I can erase all this? Can you erase this? Okay, well, let's put that back. Chlorine is 35, calcium is 40. Okay? The next step, number 2, is total mass of each element. What's the total mass? What's the total mass of calcium? What's the total mass of calcium in that particle? There's only one calcium. Let me think. There's only one calcium. Each calcium has a mass of 40. So what would be the total mass of calcium, Musaba, in that particle? What? No, what is not the answer? You were not paying attention, and it was clear that you were not paying attention. What is it?
40.
Are you guessing or taking ownership over your answer?
I'm guessing.
And saying you're guessing. Okay. Very honest. Anybody want to tell me the total mass of calcium in CaCl2?
It's just 40.
They're all stunned. What is it?
It's just 40.
40, right? It's very early in the morning. They left their minds. They have not yet connected their bodies with their minds. Their minds are still home sleeping. Excellent. So calcium is 40, right? And what is chlorine? What's the total mass of chlorine in the particle?
70.
70. Oh, there, you're starting to wake up. Excellent. So far, so good?
Yes.
Okay. Yes? Now, divide mass, total mass of element divided by what? Total mass of element divided by what? Anybody know?
Atomic mass of the
Atomic mass of particle. Okay? Particle. I can spell times 100 to give it a percent, right? So what is it going to be? So that's going to be 40 divided by what? 110 times 100. What's that equal? Yes, I can't do it mentally myself. Yeah, so why don't you take out your calculators maybe? They're like staring at me like, are you guys here today? Are you not here today? Take out your calculators. You have your calculators? Anybody have a calculator?
36.6.
What is it? What is it?
36.4.
All right, we have a 36.6 over here. We have a 36.4 over here. Anybody want to give me the right answer?
36.4.
36.4, okay. So that's 30, excuse me? Are you all right? Are we all right with that? 36 point what? 4% calcium. And so there's only 2 elements, right? So what would the chlorine be?
100 minus 36.
100 minus 36.4, which would be 63.6. 63.6% chlorine. Are we all right with that?
Yep.
Yes or no? That's it. That's all you do. If you have a very complicated problem, you simply have a larger mass, correct? And you have more than one element. More than 2 elements. Easy? That's all. And we'll do one. Now what I want to do is I want to show you how to do the empirical formula. Okay, it's a little weird, but with 2 elements it's very simple. It gets more complicated as we do 3 and 4 elements, but it's still very doable. Okay? So let's do the empirical formula and we'll write a recipe as well. Okay? All right? So I'm going to get rid of all this. Clear? The only thing I want to keep is this down here. This is the percentage of calcium and chlorine, okay? Okay? All right, the first thing you do is if you have percent composition, you rewrite the percent compositions in terms of 100 grams. So in 100 grams, how many grams of calcium would you have? If you took 100 grams of calcium chloride, how many of those grams would be calcium? 36.4 grams, right? So you base it on 100 grams. Base on 100 grams. Okay? If you're given percentages. Given percents. Okay? Yes? Okay? So you have 36.4 grams of calcium and 63.6 grams of chlorine. Correct? Yes? Easy? Easy, very easy, right? Next step. Convert to moles. Okay? Convert 36.4 grams of calcium to moles. Okay? Let's look at the equation to calculate. How would you calculate moles? How would you calculate moles? Look at chapter 10. How would you calculate moles? What's the mass in grams? Let's set up a proportional relationship, okay? Can we do that? I like proportional relationships in chemistry. I really dig them. I mean, I just love them, okay? So let's look at a proportional relationship. What's the mass in grams of 1 mole of chlorine? What are we doing first? Calcium. What's the mass in grams of 1 mole of calcium? The mass in grams of 1 mole of any particle is equivalent to the mass of 1 particle in atomic mass units. Yes? 40 what? Grams. Okay? So, it's going to be 1 mole calcium over 40 grams. Correct? Isn't that right?
Yeah.
So then you say X moles over 36.4 grams. And what does it equal? Calcium is how many moles? 1 times 36.4 divided by 40. Cross multiply and divide. So take out your calculators right now. Okay? Mr. Darcy is becoming a little frustrated that you don't have your calculators with you.
0.9.
Right? You want to not mumble, maybe, would be good. 0.9. 0.9. Anybody want to give it to me? 0.91. Yes? Okay, so 0.91 moles. That's the moles of calcium. Yes? So what did I do to get that? I actually said this divided by this. This is actually what? This is, we're not going to do the formula yet. I'll give it to you in a minute. Okay? So let's set up the next one. 1 mole of chlorine is how many grams? What's 1 mole of chlorine? We just did this like 7 minutes ago. 35 grams equals X moles over 63.6. So chlorine will equal how many moles? Yes. What is it? 1.8. Does everybody agree with 1.8?
Yeah.
Yes? Are we cool with that? Okay, 1.8 moles. Okay, are we all right with that? Yes? Yes? Okay. Now, we only have, I'm going to erase, no, I'm going to work over here. I'll work up here. I want everything on the door. Oh! I'm filming, but we have a guest. No, come in. We have a guest. Lynn is actually, we call her the hidden principal. We have principals. We have 3 or 4 principals and assistant principals, but Lynn Brown is the actual principal of the building. Yes? Yes. How may we help you?
I am looking for Eva.
She is here, present.
Kinga.
Kinga is present.
And Ismail I can see.
Ishmael she can see, which is a good thing. Well, maybe a bad thing, but anyway. Thank you. Yeah, that was a nice little, nice, yeah, that was good? Okay. Now, we'll work up here. Okay? Now what you do, it's very simple. Look. What does mole mean? What does the word mole mean? It means what? A number of particles, right? Yes? Yes or no?
Yes.
Yeah. So let's say I have 2 types of eggs. We're pretending here. I have 2 types of eggs. Brown eggs and white eggs, right? Okay, you all right with that?
Yep.
I have a dozen brown eggs and 6 white eggs. What's the ratio relative to dozens of brown eggs to white eggs? What's the ratio? 2 to 1, right? Right? Isn't it 2 to 1? It's 1 dozen to a half a dozen, or twice as many browns to whites, correct? Yes or no? You all right with that? Okay. Well, the same thing is true here. Do you see that we have, how many more calciums do we have, chlorines do we have than calciums?
2.
Isn't it obvious that there are 2 times as many calciums as there are 2 times as many chlorines as there are calciums? You can just take moles off and put dozens, right? 1.8 dozens, 0.9 dozens, right? So how many more dozens are there of chlorine relative to calcium? Yes, 2. Yes? So this is what you do. You want a recipe? This is what you do. Number 3, large mole value divided by small mole value. Do I actually have to plug this into a calculator? You would actually say 1.8 moles of chlorine over 0.91 moles of calcium equals what? Isn't it close enough? Do 1.8 again and see if you can get a better number. Because you're going to have to bring this out sometimes to 4 significant figures.
1.817.
1 point what?
817.
1 point, say it again?
817.
8, so 817. All right, so 1.817.
We can round it to 1.82, which will make it fit.
All right, 2, you can do that.
Just exactly 2 times.
Okay, and that's moles of what? Chlorine?
Sorry.
So what does that equal?
2.
2 to 1, right? So how would you write that in an empirical formula? Well, you have twice as many chlorines than you do calcium. So you would say the metal on the left, the non-metal on the right.
And 2 next to the non-metal.
Isn't that what we started with?
Yes.
Are you sure?
Yeah.
That's it? Easy?
Yes.
Absolutely easy. Are we okay with that? End of empirical formula, take 1, part 1. Okay, you all right with that, Simon? Is part of your brain in Denmark right now? I think so. Gets glassy-eyed when he sometimes goes to Denmark. He goes to Denmark during class often. He gets very glassy-eyed. Anybody else go traveling while you're in class? Lizzie, I'm not sure you are ever here. You're like the world traveler in class. Yeah. Where are you today? Where are you today? Northern Europe, maybe Sweden. I'm not sure. But Lizzie is the chemistry world traveler. Anybody else not here today? Anybody else want to tell me where they've been? We'll do where I've been. Mark, have you been to Texas this morning without telling anybody? Excellent, excellent. Yeah, yeah. I've been here since August, but I really haven't been. I traveled quite extensively on the weekend. I went over to Mongolia. I hung out. Yeah. My mind was there. So anyway, okay. Yeah, it's actually quite nice. The capital was Ulaanbaatar. It was very nice. A little cold, very cold. We went skating on Lake Baikal, the deepest lake in the world, 1 mile deep. Massa, did you go anywhere this weekend? You didn't go to Jordan or anything? You just hung out in Abu Dhabi? Or as the Australians like to say, Abu Dhabi. Where you from? I'm from Abu Dhabi. You from Abu Dhabi? No, I'm from Abu Dhabi. Where's Abu Dhabi? Oh, it's near Abu Dhabi. Abu Dhabi, I know, it's Abu Dhabi. Okay. All right, we're getting a little silly. Okay. Have a great day. Oh, it's a pronoun thing. Very good, Lizzie. See you later.